Our next speaker, let me see if I can share my screen, is Matteo Grandi. Can you hear me well, Matteo?
Yes, I can hear you.
Okay,
can you hear me?
Perfect. Yeah, I can hear you and I can see you. So Matteo is a project and innovation manager at Iris Technology Solutions, where he is currently focused on technologies such as 5G, artificial intelligence, big data, and smart ICT solutions. And today he's here to talk about 5G as an enabler for advanced monitoring systems in the manufacturing and process industries. So I let you to share your screen, Matteo.
Perfect, thank you. Okay, can you see the screen?
I can see the screen and now the presentation mode. Yeah, perfect.
Great.
Okay. So thanks very much, all yours.
Thank you. So good afternoon, everyone, and thank you, Alex, for the nice introduction. Thank you for all the speakers and to SECPHO for hosting this event. I'm Matteo Grandi, I'm Project Innovation Manager at Iris Technology Solution. In the past, I worked in a research center where the main focus was on advanced wireless communication network and software-defined networking applied to the early adoption of 5G in different use cases around Europe. And since 2018, I joined Iris, where I manage projects with a tangible, innovative component in the field of artificial intelligence, cooperative robotics, 5G, and in general, Industry 4.0, which is the main focus of the company. Iris, in fact, is an advanced engineering company that enables manufacturers to take the Industry 4.0 leap. Iris is specialized in real-time, non-invasive optical monitoring technologies, specifically for product monitoring applied mainly to food, pharma, and consumer goods industries, but not only. Iris developed a series of capabilities and the know-how to assist the manufacturers in their digital transformation process. And the metrics of organization of Iris gave birth to 3 technological departments: the Industry 4.0 and Artificial Intelligence department that is dedicated to pioneering solutions ranging from industrial IoT, big data, decision support system, SLAM for instance, cooperative robotics, and so on. Social mobile analytic and cloud department that is specialized in software development, cloud computing, software as a service, and let's say all these digital enabling tools for industry. And finally, we have Visum, which is a branch of the company developing inline monitoring solution based on machine vision as well as on infrared spectroscopy, Raman, and other technologies. As said by Joan, 5G is seen as a technology able to bring pivotal benefits to the industry ecosystem in comparison with the previous generation of mobile networks. 5G offers new appealing features that you already have heard thousands of times and also in the previous presentation: ultra low latency and improved reliability, massive IoT networks that are particularly important for track and tracing items in the warehouse or for supply chain status monitoring. Then the introduction of advanced network slicing as well as the enhanced broadband, allowing the wireless offloading of a consistent amount of data. And together, these benefits can really drive the manufacturing transformation in many of the industrial sectors. Increasing the flexibility in the factory floor is for many industries, the turning point, the keystone to improve the efficiency of the production process. And so to reduce the cost, but also, for instance, fostering the introduction of new products or improving the current products, the current one. Adapting the process to the fluctuation of the demand. Improving the quality of the final product means also less defect on the product that goes to the market. That translates to higher client satisfaction, fidelization, positive return on image. Well, at the end, all has an impact on the revenues of the company. And no less important is the improvement that we can get on the sustainability of the product. Reducing the waste, reducing the energy consumption or the scraps, or reducing the impact that the production process can have on the environment, not only have a positive impact on let's say the margin, and not only can make the factory compliant with the policy or regulation depending on the country, but it also can be attractive for an always larger bunch of customers that consider the sustainability of the product an important feature to be considered at the moment of the purchase. McKinsey recently published a report in which are considered all these benefits together, and they came out with some numbers, some let's say estimation, between 30 and 50% downtime reduction, 50 to 30% productivity improvement, 10 to 20% decrease of the quality cost. And in the second part of this presentation, I will show you how these numbers are reflected in a real use case where Iris is involved with a consumer good production company, which is Procter & Gamble. Of course, 5G is not alone in providing these benefits to the industry, because a plethora of technologies are in continuous evolution. Artificial intelligence, big data, blockchain, virtual, augmented, mixed reality, cloud computing, SLAM technologies, and etc. There are many of these. And they, with 5G, are the building block with the fourth industrial revolution. With this, I'm not saying that Industry 4.0 is the union of this technology. They are just the means. They are the building blocks, the necessary elements to enable, to trigger this transformation. And I like the classification that Klaus Schwab, the chairman of the World Economic Forum, did in his book regarding Industry 4.0. And he divided this let's say there's a transformation in three spheres: physical, digital, and biological, to cover the interaction we have in the cyber-physical system that are maybe the most revolutionary concept driving the industrial transformation, highlighting as the Industry 4.0 is not a change of technology, but is a change of mindset. And this transformation goes above the events. The current situation with COVID-19 caused a major disruption in some manufacturers. Different verticals have been directly affected by the health emergency in diametral opposite ways. Some had their business completely compromised and had to shut down. Others, on the contrary, had to accelerate their operation, but the driving principles, despite the time beings, remain the same. Digitizing and automation to be, let's say, as much flexible as possible. Flexibility allows to reduce the cost and reduce the reliance on human interaction, which maximize the probability of surviving for those companies who had to downshift, and maximize the opportunity of dealing with now the fluctuation that we have in the market for those companies that actually, those lucky companies that actually benefit from this situation. And if you think about it, even a stupid thing, a basic thing like the social distancing in some factories, depending on how they organize it, can produce a complete restructuring of the operation, and this can result in a reduction of the efficiency. And once we will move forward the COVID-19, this company wants to get back to their business as soon as possible, quick as possible, increasing the revenue, starting immediately and recovering the time that they lost. But now the question is, how do we encourage the adoption of 5G in the industry? And how we can understand which are the requirements coming from the manufacturing environment. So to stimulate the early adoption of 5G inside the industry, it is necessary a cooperation between different stakeholders defining and presenting the benefits that 5G can bring to the industry. And we need to define compelling use cases to demonstrate the potential that 5G has if applied to the factory, and also setting the step for for mobile network operators and the regulation authorities, for instance, about the power and the spectrum availability and the security inside the factories. And another important aspect is to identify which are the skills needed from the 5G ecosystem to foster a successful adoption of this technology inside the production plant, and also remove the preconception that I met in several industries that mobile network are expensive and they're designed only to work outdoor. And I think that in this, in the framework of the NU-funded project called 5G Solution, these three main actors, the manufacturers, the mobile network operator, and the 5G ecosystem are represented really well. The project has 5 use cases dedicated to the industrial sector. And this use case ranges from robot configuration, AGV, remote maintenance, smart appliance. But in this presentation, I want to focus on one specific use case that concentrates monitoring technology based on optical system and 5G. In this use case, we are facing the optimization and the quality asset, the product quality assessment in a consumer good production line, leveraging on enhanced mobile broadband and the ultra reliable low latency characteristic of 5G. Quality assurance and quality control are two key aspects for the manufacturing industry, which they have a direct impact on the industry business. The current approach of many manufacturers is to adopt a closed feedback control loop mechanism to control process parameters which are correlated and from which depend the overall quality of the product. Such an approach is typically used in offline quality assessment, where the product inspection happens separately from the production line. So to get valuable information about the overall quality of the bunch of a product, is necessary to inspect a statistically significant number of products. And in case of massive production affected by several different defects, the statistically significant number of products that you have to consider can be really high. And so there is an among us increasing of the quantity of scrap that is produced. Inline quality assessment mechanism, on the contrary, integrates a technique to inspect each single product at the end or during the different phases of the production. And by being an inline and automated procedure, it ensures that every product or every single component, every part that composes it, is inspected. And the data from the inspection can be used to feedback the production process in real time. And this means increase the efficiency of the overall production process. And in this specific use case with Procter & Gamble, Iris use a high frame rate multispectral camera, grabbing both in the visible and the infrared spectrum to take picture at different wavelengths of each product on the conveyor belt in order to identify the different defects that can affect the product. And the image of the product is wirelessly offloaded to a remote 5G private node that will bridge the data to a processing unit where a machine learning algorithm inspects the image, study the image, and looking for defects. In case the product results of being defective, a rejection system is triggered to take away, to grab on, from the conveyor belt only the defective product. So this is just a proof of concept, but the idea is to move the processing unit remotely, probably in the cloud if possible, and having several production lines and such several cameras operating simultaneously. The manufacturer, in this case Procter & Gamble, estimates that with this solution, they will have the possibility of reducing micro stoppages of their production line by 20%, reducing production scrap by 12%, and this translates to an increase of revenues around 6% only for this specific product. But most important is that Procter & Gamble will be able to scale this wireless solution 15% faster than an equivalent solution that works on wired technology.
Sorry that I interrupt, Matteo. You have about 1 minute or two to finish. Thanks very much.
I will use this. Thank you. The speed of the production line can also be adjusted, so the whole production system can deliver product at different rates. And it has been observed that the percentage of defects or certain defects change according to the speed and increase over time with the speed. So depending on the production rate, the available time to get the image, sending, process it, and then trigger the rejection system is of a few milliseconds. And this is where the latency becomes a crucial constraint to be addressed. And of course, every missing information could be a potential defective product that goes to the market. And the fact that the production rate can be adjusted and the in-production line is independent opens the possibility to adopt dynamic slicing approach. So we can dynamically assign network and computational resources to the production line that they need these resources in that moment. And this allows also to optimize the usage of the resource and allow the manufacturers to stay into the agreed SLA. So I can skip this slide because I provided already this information. And to conclude, this is just one example of use case providing and proving that, let's say, 5G can bring compelling opportunities to the factory of the future. And it's not just because throughput, latency, or reliability, but for the possibility of having one single standard to transfer all the information end to end. So enhancing in this way the flexibility both in the resource management point of view and also from the production process perspective. Thank you.
Thanks very much. Oops.
Alex, are you there?
Yeah, can you hear me? Because my okay,
yes,
because
yes.
I thought that my audio stopped. Okay, so thanks very much for your vision on how 5G can be applied to the industry. I have a quick question, probably very simple. So if our 5G networks that are deployed within let's say a private factory are also, my feeling is that they are going to be more secure as well than if you are using other paradigms, right?
Yeah, for sure. In 5G, there is an inner, let's say, security layer. So 5G is, we could say that is secure by design, especially in comparison to previous generation of mobile network. But you can also consider that there is a lot of work done for privatizing 5G, especially for this indoor application. And for instance, Joan mentioned a Neutrun before and this is for instance an initiative for this part, and there are 5G private nodes already on the market, both let's say from private companies and from research centers. One for the research center more actually for research, are a bit noisy, but for instance, Ericsson already has with the SuperDock a solution for this type. So you don't actually need to exit your factory and let's say get on rely on a mobile network operator, but you can run a core network even inside the data center of your factory.
I see that as a really game changer of the technology personally.
Totally.
So thanks very much again, Matteo, for your talk. We are a bit short in time, so if you want to leave your email here in case someone wants to contact you,
sure,
and we'll be moving to the next speaker.